Hi everyone, this is a walkthrough of our first lesson in our MCAS intervention class, which is covering our exponent properties. So by the end of this, we want to know how to work with exponents. We'll be able to simplify expressions. If you look to the back by the end, you should be able to simplify expressions that look like this, where we have variables with exponents, and we'll combine our rules to put them all together. First, we're going to start with a quick reminder on what exponents tell us. And that'll really help us build these rules as we go through the lesson today. So go ahead and make a note at the top of your paper. What an exponent tells us, when we have something like x raised to the power of 2, raised to the second power, that's telling us take x and multiply it by itself twice. So in other words, write x times x. So there could be other powers. If we have powers to the 3, that's saying take x and multiply it by itself 3 times. And also, if we just had x to the first power, I'm going to make a little note up top here, x to the first power, that's just saying there's one x being multiplied together. And a reminder, if we forgot from before, that x to the 0 power, anything raised to the 0, mathematicians have defined this just to be 1. So that's just a reminder of what positive exponents tell us in general. So let's jump right in and take this idea and use it to develop each of the 4 types of rules we're going to be working with to help us get these simplified a little bit shorter. All right. First one is going to be a product of powers. So this is where we're multiplying 2 terms together. So we're multiplying terms, and that means we're going to do something in particular with the exponents. We're going to figure out what that rule is right now. To discover this rule, I'm just going to write out, I'm going to expand this whole thing out to figure out if we can come up with a rule. We'd like to just have a coefficient, our variable x, our base x, and then some exponent up top. So our goal is to fill in this. Hopefully we can have a simple way to do that. The first term, I'm going to expand it out. It's equal to 2 times x times x times x times x times x. There's 5 x's being multiplied together there. Then the second term is 3 times x times x. So I just took our product and I expanded it all the way out into all the individual things that are being multiplied. Now I want to start, I'm going to isolate the coefficients, the numbers. I can isolate those pretty easily. I'm going to highlight them in orange there. 2 and 3 are being multiplied here, and they multiply to just 6. So the coefficient's pretty simple. I want to figure out how many total x's we have being multiplied together though. See, I see we have 5 here, and then 2 here. So in total, we have 7 x's multiplied. Oops, I'm doing so great with the spelling today. So what I want to know is, like, yes, I could do this every time. I could write out all the different things in a single line and combine them, but I'd like to have a shortcut. And the shortcut here, how could I take my 5 and my 2 to come up with our total, which was 7? Well, 5 plus 2 is 7. So the rule will just be to go 5 plus 2. So when we have the same base, we're multiplying them. We're going to add the exponents to get their result. So multiplying terms equals add exponents. Great. And a reminder, when we're doing these videos, this is the notes, this is what I do. I'd like you to take a couple seconds, pause the video, try out the second question, the example 2 by yourself, using the rules we just talked about, where we're multiplying terms, add exponents. So hopefully you paused the video and tried this out first, but I'm going to walk through it right now. So I could do the same thing here. I could try and write out my 8 x's and my negative 1. I'm not really sure yet. We'll cover that in a second, what a negative power means. But I just want to apply our rule. Our rule should work here. If we're multiplying terms, add their exponents. So if I do that, first I'm just going to take care of the 2 and the 5. Those are straightforward. 2 times 5 gives us 10. And then for the x's, my exponent here was 8. My next exponent was negative 1. So I'm going to write 8 plus negative 1. And okay, so I'm adding a positive to a negative. That's just going to be 10. That's the same as 8 minus 1. Oops, x to the 8 minus 1. which is the same as 10x to the 7th. So here we used our rule, which was adding the exponents to make this a lot simpler rather than writing out 8 x's and a negative 1x, which is, we'll find out, a divide by x, canceling it to get to x to the 7th. All right. Next, we're going to look at, I'm actually going to jump ahead to these negative powers since we just saw that pop up here. Negative powers really mean if a positive power, like we talked about at the beginning, means multiply it by itself that many times, a negative power means we divide by base. So instead of having x times x times x times x here, or 4 x's multiplied, we want to have 4 x's divided. So the way we convert that is rewrite it as 1 over, so 1 divided by x times x times x times x, or 1 divided by x to the 4th. So whenever we see a negative exponent, it means instead of multiplying it, divide it that many times. So just write it as 1 over x to the 4th, 1 over. So let's do that here. X to the 4th is going to turn to 1 over x to the 4th. Y to the negative 2, we have a negative exponent, so that means divided by. So go 1 over y squared. These are being multiplied together. I don't have to write these as 2 separate fractions. I can kind of combine it into 1 fraction. We multiply them, we just go straight across. 1 times 1 is 1. X to the 4th times y squared. X to the 4th times y squared would be one nice fraction like that. All right. So again, I did the example over here. You should copy what I did. And you're always welcome to pause and just fill in gaps that you missed if you're just listening to fill in the notes. But now you should pause, try out this example over here to simplify it. Your goal is going to be to write it without any negative powers. So hopefully you paused it, but otherwise we're going to step through this one now. So right off the bat, I see an x to the negative 5th. So whenever I see a negative exponent, I'm thinking to myself, well, I'm dividing by it that many times. I'm dividing by x to the 5th. So instead, I'm going to write it as 1 over x to the 5th. And then my y to the 6th, well, that's just a normal quantity. It's a normal exponent, so it's still just y is being multiplied 6 times. All right. So now I've gotten rid of my next negative exponent. I'd like to make this a little tidier. I see there's a fraction here being multiplied by a number. So I'm just going to write both of them as fractions. A good way to do that, if you have like this y to the 6 isn't already a fraction, I just put it over 1. That doesn't really change the quantity, it just turns it into a fraction. Now we're multiplying fractions, I multiply fractions straight across. 1 times y to the 6, it's going to be 1 times, well, that's just y to the 6th. And on bottom, x to the 5th times 1 is x to the 5th. So we took this negative exponent expression and just rewrote it as a division problem. It's a little bit neater not having the negative exponent. All right. Great. So now we've seen product of powers, we've seen negative powers, and we've seen the next I'd like to cover the quotient of powers. We'll come back to this one. When up here we multiplied bases, we multiplied terms, and we ended up adding their exponents. So the quotient here, we're dividing terms, If I'm going to make a conjecture, if it's a multiplying resulted in adding, I would say dividing is going to result in subtracting, because those are the inverses of each other. So that's my conjecture, exponents. That's my conjecture. Let's check if it makes sense given our rules. So I'm going to zoom out a little bit here. I'm going to rewrite this expression off to the side here so we have more space. I'm actually just going to isolate just the x's, because I'd like to simplify this. I have x on top, I have x's on bottom. I'd like to combine them in some way. I just need a rule to do that. Well, I'm going to use my definition of exponents. I'm going to write this top one as 5x's multiplied. And on bottom, I have 8x's, so I'm going to put these 8x's on bottom. Okay, so this is kind of a lot of work to spend out this way, which is good, so we're going to come up with a better rule. But now if I'm going to take this highlighter, I'm going to cross out my pairs, because when I'm multiplying and dividing by something, they cancel out to just be 1. So I'm crossing out pairs, and I see I'm just left over with 1, 2, 3 x's on the bottom. So I see that once these are all canceled, those all become 1s because it's something divided by itself. I'm just left with 1 over 3 x's multiplied, or x to the third, which is the same as x to the negative third, based on what we just talked about up here. Dividing by x to the third is the same as x to the negative third. So basically, I want to come up with a rule that allows me to take this 5 and this 8 and come up with negative 3. Well, if I'm just looking at it, it looks like we took 5 x's on top and we subtracted 8 of them from the bottom, and we had negative 3 left over. We had 3 left over on bottom. So it looks like our subtracting is going to work. In other words, if I were to write it here, my rule would become x to the whatever we had multiplied, 5, take away what we divided, the 8, and then I'm going to do the same thing now for the y's, y to the 7th minus 2. There were 7 y's being multiplied on the top of this fraction, 2 being multiplied on the bottom, so net, the overall is going to be 7 minus 2. And then I can rewrite these. That's going to be x, 5 minus 8 to the negative 3, y to the 5th. And then if I wanted, I could also rewrite this negative exponent equals, I'm just write it below, 1 over x to the third times y to the 5th, which is the same as y to the 5th over x to the third. Again, converting these as fractions, division. Converting this both to fractions and multiplying. Okay, cool. So try out this example over here. Our rule is when we have things on top and bottom of a fraction, when we're dividing terms, we can subtract their exponents and they have the same base. So try that out over here, pause the video, and then come back and check your answers. Hopefully you've paused, but right here, this is our, again, a division problem. I see x to the third on top, x to the fourth on bottom. So if I'm going to apply my rule, I want to subtract how many we're dividing out from how many we're multiplying. So x to the third, that's how many we're multiplying. Take away the ones we're dividing, 4. For y's, y squared, take away, and again, it doesn't have an exponent written here, but this is the same as, that's just one y. There's just one y being divided on the bottom. So 2 take away 1. Okay? If I rewrite that a step further, 3 minus 4, that's going to be negative 1, because I took away 4 from 3, so 1 more than that was. And 2 minus 1 is just 1. So this is a valid option. We want to be able to see it in all the different forms though. So I'm also going to get rid of this negative exponent and rewrite it as a fraction. Also, this y to the 1, that's kind of unnecessary. I can just write that as y. So on top we have a y, and then the first bit turns into 1 over x to the 1. X to the 1 is just the same as x. Fraction times a number, I'm turning both into fractions. Y over x. So again, we took this big mess over here and we're able to simplify it into something much simpler using our rule. All right, I say the best one for last. This one's pretty straightforward. We're really just taking what we know about exponents and applying it to this special case here. So again, I'm going to write out just what we know using exponent rules, which is, to me, it's saying take whatever's inside these parentheses and multiply that by itself 4 times. So whatever's in here, well, there's 2x cubed in here, so I'm going to multiply it by itself 4 times. 2x cubed times 2x cubed times 2x cubed times 2x cubed. So this is a totally valid approach. It's going to get us the right answer. It's going to end up being hard if we had to write it out much more than 4 times, though. And I'm going to say overall, what's left over after we've done this? Well, I see there's 1, 2, 3, 4 2's being multiplied together. In other words, it's going to turn into 2 to the 4th. 4 2's being multiplied together. And then I see there's 1, 2, 3, 4 groups. There's 4 sets of x cubes. In other words, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's in total. So x to the 12th. And then I could simplify the 2 to the 4th. 2 times itself 4 times is 2 times 2 is 4, times 2 is 8, times 2 is 16. So it'd be 16 x to the 12th. So this works. It could get tedious, it could get long if we had to write out a bunch of them. So instead, we'd like to apply a rule. If I'm looking at this problem, I see how could I use these exponents to come up with our result, 3 and 4 to come up with 12. Well, we actually ended up kind of doing it anyway. We saw that it was 4 groups of 3. To find 4 groups of 3, that's multiplication. So when we have power to power, we're going to multiply the exponents, multiply. Which works great for our x's because it's easy to see what the exponents were. 4 times 3, or 3 times 4. For the 2's, it was hard to see what this exponent was, but if I remember, the exponent on 2 would just be a 1. There's 1, 2 there. So I'm multiplying 4 times 1, like that. And then I can simplify a little bit again. 2 to the 4th, x to the 12th, and we know that 2 to the 4th is 16 x to the 12th. Right. Multiply exponents. That's our rule. Great. Again, pause the video, try this one out. This will be the last one, and then we'll move on. Hopefully you've tried this out. This is our power to power property. I see I have something in here with exponents on it, all raised to another power outside. So I'm going to try and apply our rule straight away. I know that I'm going to multiply the exponents. Well, it's really clear to me that the exponent on x is 4. So the x's are easy. It's going to be x to the 4 times 2. But on the 3, I got to remember that that's like a 1 there. So it's a 3 to the 1 times 2, or just a 3 squared. Overall, I'm going to be left with 3 squared, x to the 8th. 3 squared is 3 times 3, which is 3 times 3 is 9. 9x to the 8th. Great. So we've walked through these 4 examples, or these 4 rules. When things are multiplied, we added up their terms. When they're divided, then we subtracted. If we have a negative exponent, it means divide by that instead of multiply. And then if we have a power raised to another power, we end up multiplying those exponents to get our result. So what we should do for this, there's practice on the front and back. These problems get pretty quick once we're used to them. Independent practice down here, there's 6 problems. Work through these, check with your intervention teacher, ask questions if you're confused. Then up here, it's just more application of those, simplifying. We may be applying more than one rule up here. And then this is the mastery. This is what your intervention teacher will grade that you did independently to show that you've learned and mastered this skill. You're ready to knock it out of the park on the MCAS. All right, see you next time.